This video will go over section 3.6 on polyatomic ions. So if you look at the name polyatomic ions, so these are ions made of several atoms. In poly means several, atomic refers to atom. So it's ions made of several atoms. And so a polyatomic ion is a cation or an anion that contains more than one atom. And so the multiple atoms are held together by covalent bonds. So it is very strong bonds that holds the atom together. And so they behave as one ion, they stay as one unit. The molecule has an overall charge associated with it. So that's why they are called ions. What is illustrated here, for example, in the plaster cast, calcium sulfate is made of the metal calcium and a polyatomic ion called the sulfate ion. If you look at the model that shows the sulfate, you see the sulfur atom in the middle, yellow. And then it's surrounded by 4 oxygen atoms that are represented by red spheres. And so they are held very strongly together. And this ion has 2 negative charges. So that's the sulfate ion, for example. To the right, fertilizers are often including ammonium and nitrate. And so here it's ammonium nitrate, a compound made of the ammonium ion. It's a polyatomic ion made of nitrogen. Nitrogen is the blue sphere in the middle. And then the hydrogens, there's 4 of them. It's the white spheres bonded to the blue sphere. And the ammonium ion is the only polyatomic ion that has a positive charge. You will see in the list. And then we have another illustration of the nitrate ion. The nitrogen atom is in the middle in blue, and it's surrounded by 3 oxygen atoms that are red. And the overall charge is a -1 charge for the nitrate ion. So this is a list of common polyatomic ions. This list is provided in the reference packet for Chem 121, so reference for Unit 1 and the reference for the whole course that you will get later on. So it's a good idea to always have this list handy. So you see that polyatomic ions are typically made of nonmetals, right? Hydrogen, nitrogen, chlorine, carbon, sulfur, and phosphorus are all nonmetals. And typically the nonmetal is bonded to oxygen, which is also a nonmetal. And so that's why the bonds between them are covalent bonds, even though they are ions overall. And so, for example, nitrogen binds to oxygen to make the nitrate ion. And when there is 1 less oxygen, it's called the nitrite ion. So typically the names for polyatomic ion ends in ate, A-T-E, or ite, I-T-E. The ate version of the atom of the ion has more oxygens than the version that ends in ite. Nitrogen also makes the ammonium ion. It's the only positive polyatomic ion in that list. All the others are negatively charged. So most of the endings are in ate and ite, but there are some exceptions. And the first one here, the hydroxide ion, is an exception. It ends in ide, like the monoatomic ions. The monoatomic ions are those ions made of just 1 atom, like nitride, oxide, sulfide, fluoride, chloride, bromide, iodide. So these are all single atoms ions. But here the hydroxide is a polyatomic ion because it's oxygen bonded with hydrogen and it carries one negative charge. And it's called the hydroxide ion. It's a fairly important ion you will see in chapter 9 with acids and bases. Another exception in the ending of the names is cyanide, also ending in "ide", but it's not a monoatomic ion. It's a polyatomic ion made of carbon and nitrogen with one negative charge. So you can look at that list and have it when it's needed. It's good to keep it under your eyes and have it printed if you can. So we will learn to write formulas for ionic compound that contain polyatomic ion. So let's use an example to learn this. And we will write the formula for magnesium nitrate. So we have the name magnesium nitrate. And so from this, we need to find out the formula of that compound. Identify the cation and the polyatomic ion is the first thing you want to do. And so magnesium is Mg, symbol Mg, and that's a predictable ion found in the periodic table in group 2A. Magnesium will give a magnesium 2+. And the nitrate ends in 8. So you want to look at your list of polyatomic ion and find the nitrate ion. And nitrate has for formula NO3 -1. So now we will balance the charge and try to find the formula that is neutral. And so here magnesium carries 2 positive charges and nitrate only 1 negative charge. So to cancel the 2 positive charges from the magnesium, we will need 2 nitrate ions. So this way we will cancel all charges and we'll have a neutral formula. So you always write the formula by writing the cation first and then the anion. And here it will be Mg NO3 2 times with parentheses around NO3. So magnesium, we need only 1. The subscript 1 is implied for magnesium. And then the nitrate, we need 2 of them to cancel the charges on the magnesium. So to show that we need 2 nitrate, we will put parentheses around NO3 and then write a subscript 2 in the lower right corner as a subscript to show that it's 2 nitrate per magnesium. And when you write the formula of ionic compounds, you drop the positive and negative charges because they have been cancelled to make that formula. So they should not be written in the compound formula. So let's practice by writing the formula for sodium nitrite. Sodium is the symbol Na. Sodium is a predictable ion found in group 1A. So it's Na+. Nitrite, you need to find nitrite in your list of polyatomic ion. It ends in "ite", so it's a polyatomic ion. And the nitrite ion is NO2 -1. So Na plus NO2 -1 will make the compound NaNO2. Here you don't need to do the crisscross trick to see that 1 ion of each will make a neutral formula because Na plus, the plus will cancel the negative charge on the nitrate. And so when you have only 1 of polyatomic ion, you don't need the parentheses. Parentheses are used only if you have more than 1 of the polyatomic ion. So that's why here it stays as NaNO2. Second example, write the formula for barium sulfate. Barium, symbol Ba, found in group 2A, is an alkaline earth metal. So group 2A means it's going to be a 2+ ion. Sulfate ends in 8, so it's a polyatomic ion that you need to find in your list. And the formula for sulfate is SO4 -2. And so Ba2 plus SO4 -2, when you put them together, you see that the charges will cancel because barium carries 2 positive charges, sulfate carries 2 negative charges. It's the same number of opposite charges, so they cancel out. And so you need just one barium and one sulfate. And so the formula is BaSO4. Again, we don't need parentheses around the polyatomic ion because it's only one. And we just write the formula like this. And so the overall charge is 0, and that's the proper formulas for those two. Let's practice more with the formula for aluminum hydroxide. Again, you want to pause the video to do this on your own before you watch the answer. So aluminum is a metal from group 3A. It's a predictable ion from group 3A, so we know it's aluminum 3+. Hydroxide, even though it ends in "ide", it's not one of those monoatomic anion. It's a polyatomic ion of formula OH-. So you write the formula by having the positive ion first, then the negative ion. And here you can use the crisscross trick. And so the 3 from the aluminum 3+ will become the subscript for OH. And the 1 from OH will become a subscript for aluminum. So the formula will be Al OH 3 times. So you need parentheses here to show that there is 3 hydroxide ions for 1 aluminum ion. And we can verify that 1 aluminum ion carries 3 positive charges, and they will be cancelled by the 3 hydroxide ions because they each carry 1 negative charge. So that's the formula for aluminum hydroxide. So write the formula for ammonium phosphate. Ammonium is not an element from the periodic table. It's a polyatomic ion. This one you probably need to learn because you could search for a long time in the periodic table and not find it. It's the polyatomic ion that is positive, the only positive one in the list of polyatomic ion you have. Phosphate ends in 8, so it's a polyatomic ion. And you need to find it in your list. And using those two formulas, so NH4 plus and PO4 3-. So you want to place first the ammonium, then the phosphate. You can do the crisscross trick here. Be careful with how you do it. It's only the number in front of the charge that moves. You need to keep the 4 with the hydrogen in ammonium because the 4 here means 4 hydrogens for 1 nitrogen. So it's only 1 that will be a subscript for the phosphate. And then the 3 negative charges from the phosphate, you take the 3 and you make it a subscript for ammonium. And so PO4 stays complete with the 4. Because the 4 here means 4 oxygen for 1 phosphorus. So the formula is NH4, and we need 3 NH4 plus and 1 PO4, 1 phosphate. So we need parentheses around the ammonium because there is a need of 3 of them. So parentheses with the subscript 3 to say we need 3 ammonium for one phosphate. And the phosphate here doesn't need parentheses because it's one that is needed. Notice how the charges disappear. And so the formula is neutral this way because one phosphate with 3 negative charges will cancel the 3 positive charges coming from the 3 ammonium ions because each ammonium ion has 1 positive charge. And so that's the formula for ammonium phosphate. So now if you have a formula and you need to name, the rules are the same as before. You name the cation first and then the polyatomic anion. You do not specify the charge on the ions and you do not specify how many ions of each type are needed to balance the charges. So it's really the name of the cation followed by the name of the polyatomic anion. And here for polyatomic ion, it's just the name as it is listed in the list of polyatomic ions. So it's a good idea to recognize polyatomic ions, even though we will not test you on, naming and giving the formula. You want to get familiar with those formulas to recognize them when they are in ionic compound. That will save you a lot of frustration, and also for balancing, it is important to recognize them. So here we have 3 examples, like Na2SO4. You want to recognize that you have sodium with the sulfate ion here. SO4 is the sulfate. FePO4. So here we have iron, and because it's a variable charge metal, we need to specify what is the charge of iron in that particular compound. And so for this, if you recognize PO4 as the phosphate, then you look at your list of polyatomic ion and see that the phosphate has 3 negative charges. If phosphate has 3 negative charges and there is only 1 iron to cancel those 3 negative charges, then iron has to carry 3 positive charges. And so that's why its name is iron 3, to say that it's Fe3+. And phosphate. Notice how we just use the name of the polyatomic ion. Al2CO3 3 times. Here it's aluminum. Aluminum doesn't need a Roman numeral. It's a predictable ion from group 3A. And here it's easy to see that we have a polyatomic ion because it's in parentheses. So parentheses are a good indicator that you have a polyatomic ion. And it shows you the formula for that polyatomic ion, CO3. CO3, if you look at your list of polyatomic ion, it carries 2 negative charges and it's called the carbonate. So then the name of this compound is aluminum carbonate. So let's practice with those ionic compounds. I want you to stop the video, to pause the video to practice yourself. So NaHCO3. Here, hopefully you recognize Na, the sodium metal. So the name will have sodium to start with. Then you want to look at HCO3 in your list of polyatomic ion and hopefully recognize it. And HCO3 is the hydrogen carbonate, also called bicarbonate ion. So sodium being in the first group of the periodic table, group 1A, is a predictable ion, so we don't need a Roman numeral. So the name then is sodium bicarbonate or sodium hydrogen carbonate. Both names are correct. Now CuNO2 2 times. Cu is copper. So copper is a transition metal, it's in a B group. So it's a variable charge metal. It's not one of the exceptions like zinc or silver. So we will need to find out the charge on copper from this formula. So we need to find NO2 in the list of polyatomic ion. And NO2 has one negative charge. It's the nitrite ion. And we have two nitrite ion. So 2 times 1 negative charge, it's 2 negative charge in total. 2 negative charges in total need to be cancelled by 2 positive charges. And there is only 1 copper atom, so that copper atom needs to be Cu2+. So we have Cu2+, NO2 negative 1. And so the name will be copper 2. We need to say 2 in Roman numeral because copper is a transition metal. And here in this compound, it's 2+. So we need to say in the name copper 2. And then we add the name of the nitrite ion. And so the full name of the compound is copper 2 nitrite. Now, KClO3. KClO3. K is potassium, an alkali metal from group 1A. So it's K+. And then ClO3, you look at the list of polyatomic ion, you find that it's 1 negative charge and it's called the chlorate ion. So K+ and ClO3 negative 1 together form the potassium chlorate. You take the name of the cation, potassium, and the name of the polyatomic ion, chlorate, and put them together. Here there is no need for a Roman numeral because potassium is part of the predictable ions. So you have available in the reference packet or reference for Unit 1 this flow chart that shows how to name ionic compound. So at the top here in green, it reminds you that ionic compounds are made of metals and non-metals. First, you name the metal or ammonium because ammonium is a positive ion, so it will be first in the formula. If your metal forms only one positive ion, it's a predictable ion and you just use the element name or ammonium. If your metal forms more than one positive ion, it's a variable charge metal. And so you will need to use a Roman numeral after the name of the element. And the Roman numeral must equal to the charge of the element in that compound. And then you name the nonmetal. If it's a monoatomic ion, you just take the root of the name and end in "ide." So for example, chlorine becomes chloride. If it's a polyatomic ion, just use the name as it is found in the list of polyatomic ion. And that ends section 3.5, 3.6, sorry.